Any doubt? You can ask. So this is what about this chapter. Now at last I want to say one thing. So if you see that in text question, the page number, anybody can tell me? The page number, if you notice it.
236, sir.
Yeah, 236. So all of you open 236. So there, if you notice it, there they have given one question. You might be checking. So everything I have been taught you. So now, so if we'll see, we explain the different ways to induce current in a coil. That is the last concept for our board exam. So what is the methods, guys? First method, anybody? So what is the method for that question? You can see. So in text questions, page number 236. What is the methods of inducer current? Anybody? First man. By moving the coil in a magnetic field. Yes or no? By moving a coil. By moving the coil in a magnetic field. Means like a conductor or solenoid, whatever it is. Magnetic field. So that we can produce the induced current. Next. By changing the magnetic field around the coil. That is the thing. Means with the help of electricity. By changing the magnetic field. So with the help of current, we are doing the same thing. Yes or no? Magnetic field around the coil. So these are the two methods. Okay, explain the different ways to induce the current is by moving the coil in a magnetic field, and the second one is by changing the magnetic field around the coil. So this is what I want to say you. Now one important thing I will say you. So as I told you, this, as we know, to identify this one, so with the help of induced current, we're having two kinds of applications. One is what? Generators will work with the principle of induced current, electromagnetic inductions, generators, and as well as you might be know the transformers. Have you know transformers, guys? Please respond. So transformers you might be heard, yes or no? So transformers are again two types. One is step-up transformers and step-down transformers. Means increasing or decreasing current, we will use this step-up and step-down transformers. So generators and as well as transformers will work in the principle of called as, what is the principle, guys? Electromagnetic induction. What is that? Electromagnetic induction, and we can find the direction of induced current with the help of two laws. As I told you last class, with the help of two laws. What is the two laws? One is Lenz's law. Understanding Lenz's law, but this law now we won't study. We'll study in the class 12. Now the second law which I already studied. What is this, guys? Fleming's
right hand thumb rule.
Right hand thumb rule. Understanding? Right hand thumb rule. Now I will say you how the transformers will work. So as we see, this is the Lenz's law we'll study now, it's not needed. So as we already know, Fleming's right hand thumb rule. So that to use the three fingers of right hand, so that we know that the middle, the index finger will indicate what, guys? The index finger is indicating, or else we can say forefinger. So forefinger is indicating what? The forefinger is indicating magnetic field. Yes or no? Yes, so the magnetic field, that is what B, and as we know the thumb is indicating motion, understand, and as we know the third one, so that is what? The middle finger. So the middle finger is indicating what, guys? The middle finger is indicating
Induced current.
Induced current. That is what you have to remember. So this is the thumb and this is the middle finger. So last class I told you correct how to find that also. We have been done for the first experiment. Yes or no? So that experiment, this experiment, when the current, a straight conductor is passing, oscillating between a horseshoe magnet, north and south pole, then I have been shown you the directions how to find it is. Yes or no, Arvind? So this is what it is. So if you'll apply the Fleming's right hand thumb rule here, this is the direction of magnetic field. So if you'll imagine, then if it is moving up, then you can see if you'll apply the two fingers, then the third finger is indicating the direction of induced current. So it will be, notice it. So the induced current will be either A to B. So if you imagine this is B and this is A, then either the current will pass from B to A or from A to B. So some direction it will takes place. So based upon the upwards or downwards. So that is what you have to remember. So we have to apply the Fleming's right hand thumb rule. So now during up, the current is passing from A to B, and during down, the current is passing into another direction. That is what you have to remember. So that is only Fleming's right hand thumb rule, which we will use to find the induced current. That is what you have to remember. So now here, if you notice it, I want to say you the important thing. For example, this is what forgot about it. Now in this experiment, last experiment, if you notice it, we are inducing the current by changing the magnetic field. Yes or no, guys? Please respond. We are in this experiment. So we are inducing the current with the help of change in magnetic field around the coil A, so that the magnetic field in around coil B is also changes. So which is causing change in magnetic field causing potential difference. So potential difference is inducing the current. So now if you notice it, if for example, like how the transformer will work. So if coil A is connected to alternative currents. See, till now we connected to direct current. Understanding means fixed voltage. Now if I have been connected to alternative current, I don't know, means it is increases or decreases. So like that. So then this is what we used to say alternative current. So if the coil A is connected to, please respond. So this is the coil A. Okay. So now if the coil A is connected to coil B, coil A is connected to alternative current, AC current. So we are having two types of current. One is AC current, another one is what, guys? DC current. So before experiment, we have been done DC current, one time on, one time off. But if the coil A is connected to AC current, alternating current, which keeps on changing, it is not constant value. So in DC current, what is happening? It will start from 0 amperes and will comes to steady value. Do you understand, everybody? It will comes to what? Steady value, and it will be fixed there. But in alternative current, it is not fixed. It is keep on changing current. One time increases, decreases, little bit more or less, that keep on changes. If the coil A, the current is keep on changes, then coil B, what will happen? Anybody can tell me? Coil B, what will happen? Then the constant current is produced in the coil B. That is what will happen. That is what you have to understand. So that when the current is keep on changing in coil B, then the constant current is produced in the coil B. That is what the phenomena, how the transformers will work. So that the constant current will be induced in the coil B, whose magnitude will depend on the relative number of turns of the wire of coil A. So here more number of turns, more magnetic field changes, so that here more current will produce. So that is why the constant current which is produced in the coil B, when A coil is connected to alternative current, which will keep on changes, then it will be depend on the constant current is produced in the coil B, which is depends on number of turns of coil A. Because if more number of turns in coil A, so that more magnetism is induced, so that it is causing more induced current. That is why you can see coil A is always more number of turns, coil B less number of turns. So that is why we can say, so the magnitude of the induced current, the constant current in the coil B is depends on the relative number of turns of wire coil A and as well as coil B. And you can see this is the thing which we are using in making transformers for stepping up transformers. You will study in class 12th, stepping up transformers or increasing or stepping down transformer, decreasing. We are using the same principle. So it is both the relative number of turns in coil A and coil B, and how the current is keep on changes will cause us to produce the constant current in the coil B. So that magnitude is depend on both the turns of coil A and coil B. That is what you have to remember. So if we'll see, so step up and step down, the voltage of alternative current keep on increases. So these transformers only we are using in our power stations and variety of electronic appliances such as a radio set, TV set, everything we are using this alternative current only. So that is why you can see refrigerators, the geysers, fans and all, they all are having alternative current in coil A, so that the coil B, a constant current is produced. So but the amount of current which is produced here is based upon the number of turns of coil A and coil B. That is what the relative number of turns of wire in coil A and turns in coil B. That is what you have to remember. So in transformer, step up and step down, everywhere we are using, this is the phenomena, and this is what we are using in all the TV sets and as well as refrigerators, geysers, everywhere, and the radio sets and etc. etc. So this is all you have to remember. So experiment we will do with the DC current, because the current will become 0 amperes to steady value. Do you understand, everybody? So 0 amperes, this is 0, not OA guys, 0 amperes to steady value, so that the magnetic field also will no changes, only it will increases, it will become steady. That is what it is. But if it is current connected to alternative currents, then the constant current is produced in the coil B. But here what is happening? When I on the switch alone, the current is produces. So again, when I off the switch alone, the current is produces. This is what we are doing for experimental purpose, but originally real life in the step up and step down transformers. So don't think that step up and step down. So to increase the potential difference, step up transformer. To decrease the potential difference, step down transformer. So the number of turns only will varies. Understand? So step up transformers, if you take, they will keep some core material, that is a soft iron. Understand? So this is a soft iron. So here more number of turns in step up transformer. So if more number of transformer, what is happening guys? More number of turns, what is happening? More magnetic field will produce. So and here step down transformer, less number of turns. So this is what coil A and coil B, and this is what a core material which they will use as a what iron? A soft iron. Understand, everyone? So soft iron will use, so that the current will induces. So instead of here in this experiment, we are using non-conducting paper cylinder, but here we can use a core material, a soft iron, then the induced current will be more. That is what also you have to remember. So usually if you notice it, transformers will be in a rectangular shape. Have you seen guys? And here inside, if you notice it, anytime transformers repair, so it will be like this only. Okay. So step up and step down transformers. Inside, they used to keep a number of this kind of things. And here, a coil A, they will make more number of turns, and coil B, they will make the less number of turns. Same way, step down transformers. Here, they will make less number of turns, and here they will make the more number of turns for the step down transformer, and this is the step up transformer. Step up transformer to increase the current, to increase the potential difference or increase the current. Step down transformer to decrease the current or to decrease the potential difference. So that is why number of turns only, the relative number of turns in coil A and coil B will decides the magnitude of current. Understand? The magnitude of induced current depends on relative number of turns in coil A and coil B. Is it clear, everybody? So this is all about this concept. Anybody is having any doubt, you can ask. Bhumika, have you understand? Bhumika, Kavya, Sanjay, everyone? So this is only a very, very important concept where maximum in these last two experiment I am saying you. So from this Faraday's experiment, one question surely will be in our final exam also. But how the way you are answering is definitely will influence the getting a score, what you are scoring. So that is what, so to be thorough with this. So each and every line I have explained you. I hope no doubt for you all. If you have any doubt, you can ask me. Otherwise, this is all about this chapter. Then tomorrow onwards for this till this weekend, I will give you different questions for practice, and later Saturday we'll meet and we'll wind up this. Because anyhow from Monday we are having first exam, correct? So that is what it is. So this is all about this chapter. So anybody is having any doubt anywhere, you just kindly ask me. Remember, DC current means direct current, and AC current means alternative current. Understand that? So the alternative current in India changes direction. That is also I'm saying you. In our India, DC current, no change in direction. So alternative current, if you take in our India, so every 1/100 of second, every 1/100 of second, the direction of current will changes. Direction will change in our India. Okay, but it is deleted. No need. I'm just saying you. So our house, our homes and industries is everything alternative current only. So you can see only the current obtained from a battery or a cell is called as direct current. Like your experiments and all, we are using a fixed battery current. So you can take the fixed battery dry cell, positive and negative node. So that is what we used to call as a direct current, which is coming from cells or batteries and all. But if it comes to our homes and all, where the current is reverses. Okay, so AC current, the current is always reverses. Both it will travel one direction. After every 1/100 second, it will be reverse also. But in DC current only single direction. Okay, which always flow in the same direction. That is what we used to call as DC current. So same direction DC current, then which is reverses its direction after a certain fixed interval of time. Understand what is that fixed interval of time? Our India 1/100 of second. Then it is called as AC current. So it will know, if you notice it, the electricity supplied to our homes, industries, everywhere, it is AC current only. Okay, so which is fixed current means which is coming from batteries or dry cells. That is what you have to remember. So now we have advantages of AC over DC, because DC we cannot increase or decrease the voltage, so that AC currents is almost, transmission is almost negligible. So the cost of AC transmission is also low. So that is the major advantage of AC currents. And AC current at any desired voltage can be obtained using transformers. That is what step up or step down transformers. So now, but DC current we cannot get the desired voltage. But by alternative currents, by increasing number of turns, that is what this experiment. So number of turns, the relative number of turns in coil A and coil B, we can increase or decrease the desired voltage. So that is the advantages of AC currents. Whenever we require, AC can be changed into DC, but DC cannot be changed into AC current. That is what. So the magnitude of AC can be reduced using using some kind of devices like chokes without involving loss of energy. So that is what you have to remember. So that is why alternative currents only we are using most of the places, houses, industries and all, instead of DC current, because DC current we cannot use it normally. So disadvantages of that is, and even we have a disadvantages of AC over DC also there, but advantages also there, but that is all not there for you. So that now no need to worry also, no need to study also. So till here you have to end it. So this is all about this chapter. So after that, whatever it is, now no need to worry. Anyhow, the situation will come. Again, you have to study in the higher classes. So till here, be very careful and you have to study. Then definitely the questions will come from this only. That is what I can say. So with this, I leave you. Thank you, everybody. Bye. We'll meet in tomorrow's class. So whatever the pending you have, kindly complete it, guys. Whatever the pending you have, please finish it. Don't delay much time, because you won't get time after 20th. I'm saying you. Thank you, all of you.